Hello, and welcome to this lesson on applications of right triangles. Alright, so for a right triangle, this is the way that I like to label them. So I'm going to have this triangle that I'm going to call A, B, C, and I usually orient it the same way, A to the left, B on the top, C downwards. And then angle theta, I put it over here where I have the A. Now, if I call that theta, then I have my opposite side, which is the edge B to C, my hypotenuse, which is the edge A to B, and my adjacent side, which is edge AC. Now, our three main trig functions are sine, which is the opposite over the hypotenuse, cosine of theta, which is the adjacent over the hypotenuse, and tangent of theta, which is the opposite over the adjacent. Well, if we have a right triangle, and we know the measure of one angle and the length of one side, then we can find the measure of the other angle and the length of the other sides. So let's take a look at an example where we do this. So for this triangle, we want to find the measure of the remaining angle and the length of the other sides. So here, my theta, the angle at A, is 20 degrees. Got my right angle here, and I have the opposite side here, which is 5. So, looking at this, first thing I'm going to do is I'm going to find this angle up here at B. So to find the angle at B, well, if you remember, if you add up all the angles of a triangle, that should add up to give you a total of 180 degrees. So 20 plus angle B plus this 90-degree angle, that's going to give me a total of 180 degrees. 20 plus 90 is 110. Subtracting 110 from both sides, and that's going to give me that angle B is 70 degrees. So we've now found what angle B is. Now what we're going to do is we're going to find the length of side AB. So AB is my hypotenuse. So I've got my hypotenuse and I have the opposite side. Well, the trig function that relates the opposite side and the hypotenuse, AB is my hypotenuse. I know the measure at angle A, which is 20 degrees, and the opposite side is 5. The trigonometric function that uses the opposite and the hypotenuse, that is sine. So if I plug the values in, my opposite is 5. My angle is 20 degrees, and the hypotenuse is what we don't know. So that's going to be x. To solve this equation, we're going to multiply both sides by x. So if we multiply both sides by x, this gives us x times sine of theta is equal to x times 5 over x. On the right-hand side, the x's will cancel, and this gives us x times sine of 20 degrees is equal to 5. To get x by itself, we're going to have to divide both sides by the sine of 20 degrees. So I've got x times the sine of 20 degrees divided by the sine of 20 degrees is equal to 5 divided by the sine of 20 degrees. So that's going to end up giving us x is equal to 5 divided by the sine of 20 degrees. If I calculate this, well, 5 divided by the sine of 20 degrees with my calculator, this gives me that x is approximately 14.6190. There I rounded it to 4 decimal places. So we just found the length of the hypotenuse, AB. Now let's find the length of that side AC, which is my adjacent side. So AC is my adjacent side. The measure of my angle A is 20 degrees, and we know the length of that opposite side, which was 5. So we have the adjacent side and we have the opposite side, so here we're going to use tangent. Tangent of theta is equal to the opposite divided by the adjacent. So plugging my numbers in, this gives me tangent of 20 degrees, that's what my angle is equal to the opposite is 5, divided by the adjacent, and we're trying to find the adjacent. So to solve this equation, we're going to multiply both sides by x. If we multiply both sides by x, that gives me x times the tangent of 20 degrees is equal to x times 5 over x. These x's are going to cancel. So that's going to give me x times the tangent of 20 degrees is equal to 5. I'm now going to divide both sides by the tangent of 20 degrees. So x times the tangent of 20 degrees divided by the tangent of 20 degrees is equal to 5 divided by the tangent of 20 degrees. Well, this side that has the x's, the tangents divide out, and that gives me x is equal to 5 divided by the tangent of 20 degrees. Grabbing my calculator, that's going to end up giving me that x is approximately equal to 13.7374, and that's my answer rounded to 4 decimal places. Now, one thing I want you to notice, whenever we're using these trig functions, whether it's sine, cosine, or tangent, since these measurements were in degrees, we need to make certain that our calculator is in the correct mode. So if our angle is in degrees, we need to be in degree mode. If our angle is in radians, we need to be in radian mode. So if we have a right triangle, and we know one angle on one side, then we can find the other angle in the other two sides. Now let's take a look at a different type of problem. If we have a right triangle where we know two sides, then we can find the measure of the other two angles and the length of the remaining side. So let's take a look at an example where we do that. Alright, so for this triangle, I do not know any of the angles other than my right angle, and I know two sides. So when I take a look at this, I know side BC, which I usually think about as the opposite side, and I know side AC, which I usually think about as the adjacent side. So I know the opposite side and the adjacent side, but I don't know the hypotenuse. Well, to find the hypotenuse, I can use the Pythagorean theorem. So using my Pythagorean theorem to find the length of that hypotenuse, so that's a squared plus b squared is equal to c squared. That's 7 squared plus 5 squared is equal to c squared, which gives me 49 plus 25 is equal to c squared, which gives me 74 is equal to c squared. Taking the square root of both sides, that ends up giving me c is equal to the square root of 74. So that's the length of that hypotenuse, square root of 74. Now let's find angle A. So to find angle A, well, we saw that we have the opposite and the adjacent. 5 is the opposite, 7 is the adjacent. So the trig function that deals with the opposite side and the adjacent side, that happens to be tangent. So tangent is the opposite over the adjacent. If I plug these numbers in, 5 is the opposite, 7 is the adjacent. That ends up giving me tangent of theta, tangent of that angle, is 5 over 7. Now, to find out what that angle is, we're going to have to take the inverse tangent. So that means theta is equal to the inverse tangent of 5/7. So that ends up calculating to approximately an angle of 35.5 degrees. And that's the angle, rounded to 1 decimal point, is 35.5 degrees. Now, to find angle B, we already know we have a right angle, and we already know angle A. So if we add up these three angles, that's going to add to give me 180. So 35.5 plus 90, that's 125.5. Subtract 125.5 on both sides, and that gives me angle B is going to be 55.5 degrees. Excuse me, 54.5 degrees. So we had two sides. We were able to use two sides to find the third side. We were able to use those same two sides to find one of the angles, and once we have two of the that angle with the right angle, we were able to find the third angle. Alright, so let's take a look at some other examples. Now these examples are more applied other than just giving you a triangle. These are sort of more real-world problems or word-type problems. So let's say we want to find the altitude of a plane. So from a radar station, we measure that the straight line distance from the radar station along the hypotenuse is 15 miles. So my radar station is down here at A, my plane is up here at B, and the straight line distance is 15 miles. The angle of elevation from the ground to the plane, that's 20 degrees. So this triangle that I have drawn here describes that paragraph. And they want me to find the altitude of the plane, which is the height. The height is going to be this edge BC, which is the opposite side. So what we have is we have an angle, we know the hypotenuse, and we want to find the opposite. So the trig function that deals with the opposite and the hypotenuse, that happens to be the sine function. So sine of theta is equal to the opposite over the hypotenuse. If I plug my numbers in, that gives me sine of 20 degrees, my angle was 20, is equal to my opposite, which is x, divided by my hypotenuse, which is 15. So this right here describes my triangle. I now want to multiply both sides by 15. So multiplying both sides by 15, that'll give me x is equal to, because the 15's cancel, x is equal to 15 times the sine of 20 degrees. And then if I calculate that, that gives me that x is approximately equal to 5.15. So my airplane has an altitude of approximately 5.13 miles. Sorry, x is approximately 5.13. Alright, example number 4. Here we want to find the height of a pole. So the distance along the ground from the pole to a point on the ground, AC, so here's a point on the ground, and here's the bottom of the pole, so that distance is 7 feet. And then the angle from the point on the ground up to the top is 70 degrees. Now, notice this is definitely not drawn to scale, because a 70-degree angle should be closer, should be more steep, should be closer to a 90-degree angle than what this one is. So one thing I want you to be aware of is with any of these problems, never trust the picture, trust the numbers. So looking at my numbers, I've got this angle of 70 degrees, I have the adjacent, and they want me to find the opposite. So the trig function that relates the opposite and the adjacent, the trig function is going to relate the opposite and the adjacent. That's going to be my tangent function. So tangent of that angle is equal to opposite over the adjacent. If I plug my numbers in, this gives me that tangent of 70 degrees is equal to my opposite, which is not known, so that's an x, divided by my adjacent, which is 7. Multiplying both sides by 7, that's going to end up giving me 7 times the tangent of 70 degrees is equal to x. And then if I calculate this, 7 times the tangent of 70 degrees, this ends up giving me x is approximately equal to 19.2. So the height of this pole is approximately 19.2 feet. All right, let's take a look at another example. So here we have a boat sees a lighthouse. The captain knows that the height of the lighthouse happens to be 100 feet. So there's a lighthouse over here, and the height of that lighthouse is 100 feet. The captain measures the angle from the bottom of the lighthouse to the top of the lighthouse is 5 degrees. So we got a 5-degree angle right here. And we want to find out how far is my boat from the lighthouse, sort of the straight line distance, or I should say the shortest distance. So our triangle will look something like this, and we're wanting to find the length of my adjacent side. So again, I've got my opposite side. I need to find the adjacent side, and I have an angle. So that's going to use my tangent like I did in the previous example. So the tangent of theta is going to be the opposite divided by the adjacent. If I plug in my numbers, that gives me the tangent of 5 degrees is equal to 100 divided by x. Solving this equation, multiplying both sides by x, this gives me x times tangent of 5 degrees is equal to 100. If I continue to solve this, to get the x by itself, I want to divide both sides by the tangent of 5 degrees. So if I divide both sides by the tangent of 5 degrees, well, tangent of 5 degrees divided by tangent of 5 degrees, that'll give me just an x. So this ends up giving me x is equal to 100 divided by the tangent of 5 degrees. Now when I grab my calculator and calculate that, that calculates to 1143.0. So the captain is about 1143.0 feet away from the lighthouse. Alright, this one's a bit more interesting, and by interesting I mean more complicated. So we want to find the height of a pole. And what we have here is at one point we get a 5-degree angle. So when we're over here, we get a 5-degree angle to the top of that pole. Then what we're going to do is we're going to walk 80 feet towards that pole to another point, and here we measure a 10-degree angle. And we want to try to figure out what the height of that pole is when we don't even know how far away from the pole we are. Now this one's kind of handy. The one they have in the book, I used a pole here, is like if you had the top of a mountain. Well, you can't get directly underneath the mountain, so you basically have to take two angles that are off to the side of the mountain and use that to calculate the height of the mountain. So notice that what we have here are two triangles, and I'm labeling these triangles with the endpoints. I've got A, B, C, those are the corner points, and then I've got D, B, C. And both of those triangles, this height is the same. So what I'm going to do is I'm going to take a look at the smaller triangle, the DBC, first. Now we're wanting to find this height. So the trig function that's going to relate this height to my adjacent side here, which is being labeled as x, is tangent. So looking at that, that gives me the tangent of this 10-degree angle is equal to the opposite side, which is the height, over the adjacent side, which is x. And what I'm going to do with that particular equation is I want to solve this thing for height. So multiplying both sides by x, and that gives me that my height is going to be 10 times the tangent of 10 degrees. So what we did is we used that smaller triangle to build an equation that'll give us height. Now we still don't know what x is, but we do have an equation that describes height. Alright, so if I do this, for triangle ABC, I can do the same thing. So triangle ABC, I know the angle. The adjacent side is going to be this 80 plus this x, or x plus 80. And then I'm going to have my height. So that ends up giving me the tangent of 5 degrees is equal to that height, the opposite divided by the adjacent, which is x plus 80. And then if I multiply both sides of this equation by x plus 80 to get the height by itself, so that's what I want to do, is get the height by itself. So multiplying both sides by x plus 80, the x plus 80s on the right side are going to go away. and that gives me the height is equal to x plus 80 times the tangent of 5 degrees. So I've got two different equations for my height. One of those equations is up here is x is equal to the tangent of 10 degrees, and the other one here is x plus 80 times the tangent of 5 degrees. So I'm going to put those two equations equal to each other. So if I put those two equations equal to each other, that gives me x plus 80 times tangent of 5 degrees is equal to x times the tangent of 10 degrees. I need to solve this equation for x. So on this left side here, I'm going to distribute tangent of 5 degrees through. So I'm going to do tangent of 5 degrees times the x and tangent of 5 degrees times the 80. So that gives me x times tangent of 5 degrees plus 80 times the tangent of 5 degrees, and that's equal to x times the tangent of 10 degrees. Now, I want all the terms with the variable on the same side. So I'm going to subtract x times the tangent of 5 degrees from both sides. So subtract x times the tangent of 5 degrees on both sides, and this is going to end up giving me the following. 80 times the tangent of 5 degrees is equal to x times the tangent of 10 degrees minus x times the tangent of 5 degrees. So I'm now looking at an expression like this. Now notice on the right hand side we have an x that's common. If I factor my x out, that gives me x times tangent of 10 degrees minus tangent of 5 degrees. Now at this point I decided to grab my calculator, and 80 times the tangent of 5 degrees gives me this very long decimal. Tangent of 10 degrees minus the tangent of 5 degrees gives me this very long decimal. So to find out what x is, this ends up giving me the following. I get to this equation right here, and to solve that equation, we're going to divide both sides by this 0.888381718. And that ends up giving me, a value of x that is approximately 7.88. So we've calculated the value of x, that is 7.88. Now, if we go back up to our picture for this, x is the distance from D to C. So that distance happens to be 7.88. Alright, so that means I can take this x value, this 7.88, and then I can use this angle here, and then I can find what the height's going to be. Now, before I actually do that, I've got a little note that I want to kind of mention about these decimals. Up here, I used the very long decimals. The reason why I use the very long decimals is because if I round these numbers and I use the rounded numbers in a calculation, then I'm going to get a rounding error. So this 7.88 for x is a rounded number. If I use this rounded number to try to calculate the height, I'm going to increase the amount of error. So I don't want this 7.88. Instead, I want the more lengthy number, which is 0.699909308 2 divided by 0.0888381718. So that number was actually 7.87846224. So when I use this, I don't want to use this rounded number here. I want to use that very, very lengthy decimal. Now, in order to find this, we have a tangent. So this tangent's going to be the opposite divided by the hypotenuse. This opposite not hypotenuse, the adjacent. This opposite divided by the adjacent. So that means the tangent of 10 degrees times this number will end up giving me my height. So that big lengthy decimal times the tangent of 10 degrees, and that ends up giving me that my pole is about 1.39 feet high. Now, I know that's not a very tall pole, but look at what we're doing here. We're finding the height of a pole from 80 feet away. Well, 80 feet away over here, and this was like 80 plus whatever that was, the 16 or whatever. Yeah, 80. So over here at A, we were 87 feet away, and at D, we were 7 feet away. And we're actually able to do that. We found this value for X, and then we were able to use that to find the height of that pole. Well, I want to thank you for watching this presentation.